Hey, so we're going to start our last day talking about direct proof. It's not going to be our last day practicing it. We will see this method of proof come up again and again. This is our last day doing practice from chapter 4. And we're going to talk about equality and inequality proofs. So things like this. Now, let's get yourself ready for notes. We're going to get started. The new piece of notation that you're going to see is this R with the plus sign as a superscript. And this just means positive. In this case, it's the R's. So that's real numbers. And this same subscript with a positive could be the positive rational numbers. Could also be negative if it's a superscript of negative instead of plus. Hopefully that makes sense. Now, one thing that is helpful with the positive numbers is that if you're stuck on where to start, and in this case, for this proof, we have a nice hypothesis here. If x is less than y, since it's positive, if you're looking for a nice place to start, that just means that the number is going to be greater than 0. So if you're looking for a nice place to start, that's a good place to begin. Not greater than or equal to. However, in number 1, we have a nice hypothesis here. So if x, y are both positive real numbers, then prove that if x is less than or equal to y, then root x is less than or equal to root y. So the roots are why we need the positives. So we'll always start with the hypothesis if we have a nice one like this. So x is less than or equal to y. Now this is one of those cases that's really helpful to think about what we want. And we want roots here. So I'm going to say, well, I know that x is the same as root x squared is less than or equal to root y squared. And now you can't just take the square root of both sides because then we end up with a positive negative situation because of squared. Like that works with cubes, it doesn't necessarily work with squares because there's a positive and negative. So what I'm going to do instead is I'm going to subtract over the y term. And this is not something I'd necessarily expect students to be able to come up with independently, but that's why you're going to see an example and you're not going to have to come up with it independently. Now you'll notice that we have squares and a difference. Creating a difference of squares is a really effective technique for a lot of problems because then we end up with a factorable polynomial, or in this case radical. So root x plus root y times root x minus root y is less than or equal to 0. So this is just our factoring from our algebra classes before. Now, this is the important part when we talk about inequalities. We can say, since x and y are real, we know that root x plus root y are both positives, so they are greater than or equal to 0. And because if this is a positive number, multiplied to equal a negative, something less than 0, we now know that root x minus root y has to be less than or equal to 0. So then we have a positive times a negative equals a negative. Now how we can finish up, we want root x is less than or equal to root y, so I'm going to add the root y back to both sides, and we end up with the inequality that we want as the end of our proof. So this is another example of where it's really helpful to think about what do you want to get out of the end result. Now, let's look at a case where we don't have a very clear hypothesis. So in number 2, it says given that x and y are in the positive reals, again, we're looking at a proof that 2 root xy is less than or equal to x plus y. Now, in this case, we don't have a given hypothesis. And so if we had just one number, if it was just x is in the reals, I would start with our given statement here. But since we have an x and a y, I am going to always start with something that involves both. So since x and y are numbers, I know that one must be greater than or equal to the number. So I can just say, well, I know, let's say this is true. Just as easy to say x is less than or equal to y. Here I'm going to say y is less than or equal to x because we're just going to say that y is then the larger number. Sorry, y in this case the smaller number. Now, here's a really helpful technique that you can use in proofs. is that if you've already proven something's true, you can use this. So since we're interested in roots still with this problem, I'm going to say, well, using our proof from above, if two positive real numbers are in an inequality, their roots have the same inequality. And this is going to be a really helpful technique, is that once you've proven something, you can use that as its own separate theorem. Hopefully you remember this a bit from geometry classes, and it's going to be really helpful for you as we continue on in this class. Now, the next thing I'm going to do is I'm going to subtract over the root y. So similar to our previous proof, so x minus root y. And then what I'm going to do is square both sides. And since we're talking about positive numbers, that's fine. So 0 squared is 0. And then root x minus root y squared, we can expand using the binomial theorem. So that's root x squared minus 2 root xy plus root y squared. I can do some simplifying there. 2x minus 2 root xy plus y. Now I'm going to look back at the thing that we want. Oh, look, you've got all your nice terms. I'm going to add that last 2y term back over. We end up with 2 root xy is less than or equal to x plus y. So really helpful here. You can still use things that you have already proven, and they are just tools you're adding to your arsenal. Let me know if you have questions about direct proofs, about inequalities. You can sign up for Zoom sessions, or you can ask me in emails or in the comments. Talk to you later.